What is similarity? So the symbol for similarity, first of all, is the little squiggly, and this should look familiar because in the congruent symbol you have an equal sign and this squiggly on top. So just the squiggly part is what we're gonna is the symbol for similarity. Similar figures or polygons with the same shape but different size. So here are little worms with glasses. They're the same shapes but they're different size. Polygons are similar if their corresponding angles are congruent. So that means when we can pair up the angles, all the angle pairs are going to match up and be congruent. But the corresponding sides are going to be proportional, which is different than in congruent figures, which the corresponding angles are congruent and the corresponding sides are congruent. And in this case, the corresponding sides have to be proportional. In order for you to check that, you actually are going to have to set up the proportions and check to make sure. If polygons are similar, then their perimeters are also proportional. And remember, perimeter is found by adding up all the sides. So if the shapes are similar, that means whatever ratio the sides have, the perimeters also have that same ratio. So there are similarity statements which are like congruency statements. The order is important. A valid similarity statement must match the corresponding angles and sides together. So again, like congruency statements, angle J still going to match up with angle P. And remember the corresponding angles are congruent. So we write this out. We got angle J is congruent to angle P. And then we have angle K congruent to angle M. And then angle L is congruent to angle N. And so that should be very much familiar to you since we just finished that with congruent figures. Now here's what becomes different. You still, for the sides are not equal because remember the proportional, the sides are proportional, meaning they're not the same. Okay, so they have different sizes, so they're not going to be the same, but they are proportional. So that means what we can't say is that the sides are congruent, but we can say that they are proportional. So if I take the one side, JK, so JK which is going to be the same as PM. So they're not equal, but it means if I take the length of JK and divide it by the length of PM, that ratio is going to be equal to the ratio of side KL and so here KL is going to match with MN, but remember, they're not congruent, they're proportional. So you can set up the ratio. And this is also going to be equal to the ratio of the third side. So it's JL to PN. Now see some important things about me setting up these ratios and proportions. I started my top lines always came from the triangle on the left. Okay, I didn't switch. And all the bottom uh, sides came from the triangle on the right. So you have to make sure you keep the same order. If you start with something at the top, then that triangle information needs to continuously be at the top. Versus if you do it, if you flip flop, you're gonna get the wrong ratio set up. So go ahead and pause the video, and I want you to go ahead and write the corresponding angles and the corresponding sides for this figure here using the similarity statement. So here you have angle F congruent to angle J, angle G congruent to angle K, angle H congruent to angle H. And then you have side F, the ratio of side FG over JK is going to be equal to the ratio of GH over KH. It's going to be equal to the ratio of FH over JH. And so in any of these, you can form a proportion. And if you can see from the angles, I went ahead and marked them so you can actually see that these angles are going to all be, the corresponding angles are going to match up. Now remember, from congruent, there was no angle, angle, angle. Okay, so keep that in mind, what we can use this for similarity later on. Alright, so we're going to practice how to find some missing numbers using our congruency statement. So, our similarity statement. And make sure with this, make sure you're paying attention to what symbol is there, because the problems do get mixed up with each other. So here we want to find the value of x. And before we would just set them equal, but now our sides are not equal, they are proportional. So we need to set up the proportion. So if I know we need to find x, I like to start with x. So I'll go x divided by, now I know x is on DE. What's going to match with DE is AB. And AB is 25. So I'm going to come this way. So now I got x over 25 is equal to, now I'm going to come back to my original triangle, and the only other bit of information I know is here, which is the 28, divided by, now the 28 is on side EF, so what matches with EF? BC, and BC is 20. It is important to use your similarity statement to go ahead and match your pieces up so you can set up your proportion correctly. Now, we just practiced doing proportions, so you're going to cross multiply. So we get 20x. And then we multiply the 25 times the 28. And we get 700. And so now we just got to solve for x. So we're going to divide both sides by 20. And then we get x is equal to 35. So just remember, we can't set the sides equal. We actually have to set up a proportion and solve. So go ahead and pause the video and you give it a next try on this problem over here. Alright, so now your proportion can be set up x plus 6 over 36 equals x plus 3 divided by 32. And you solve that and get x equals 21. Now if you switch the order of these two ratios, that is fine as well. Okay. So we're going to do some more kind of sample problems just so you can kind of get a feel for the different type of problems that you could be asked. So in this one it says, in the figures below are similar with a scale factor of 2 to 3. Remember, ratios can be written as a fraction with the colon or the word 2. You want to find the value of x. Okay? So x is here, and since this is the only other side, and because they're similar, we know it has to go x over 42. But now we need the other side of the proportion to fill in, and that's where the scale factor comes into play. So you know that the 42 deals with the smaller number. So look at the picture. So the 2 needs to be here, and the x deals with the bigger figure, and so 3 would be bigger than 2. And we can set this up here. You could also set this up starting with this scale factor of x 2 over 3. And then you just have to match it up. 2 would be the smallest. So it would be 42 over x. Either proportion will work. And now we just cross multiply to solve. So once you set up your equation and solve, you should get x is 63. Always double check and actually make sure this actually makes sense. If you knew that this was the smaller figure and this was the bigger figure, make sure that number is bigger. Okay, so you go ahead and give it a try with question number 5. So setting up your proportion, and then you should end up with the answer x is equal to 33.6. Alright, let's look at these. Again, we're trying to find x. We're going to use our similarity statement to set up our proportion. And we've actually already done this one. So I want you to go ahead and try question 7. Okay, set up your proportion using the similarity statement and solve for x. So here is my proportion set up. I did x over 32. You see x comes from the bigger figure, 32 comes from the smaller. And then I came up here to the top where the 75 comes from the bigger figure, and down here 40 comes from the smaller one. So I made sure to keep those patterns going. Okay, so now we just solve that for x. And then this one, x is equal to 60. Alright, and so 8, we've already done that one. So 9 is very similar to 8. Go ahead and set up your proportion and then solve for x. So here's your proportion setup. Remember, I went from left to right triangle, and up here left to right triangle. And now we just cross multiply and solve for x. Make sure you remember to distribute since we have binomials there. And when you solve, you should get x is equal to 9. Okay, that's it.